Assalamualaikum and good day everyone. My name is Fatma Zahra Binti from class MT2. Today I will present my individual task which focuses on applying the guess and check strategy using Polya's four-step problem solving model. This presentation explains how the guess and check strategy is applied to solve a real-life mathematical problem using Polya's four-step model. It focuses on Amer's walking distance problem, which involves reasoning with averages to reach a specific target goal. The strategy demonstrates that by testing and refining guesses, learners can arrive at accurate results through logical and systematic thinking. Overall, it highlights that, mathematical reasoning is not only about performing calculations, but also about understanding, reflection, and thoughtful decision making in the problem solving process. The problem situation. Amir plans to walk an average of 5.5 kilometers per day over 30 days in April. In the first 10 days, he walked an average of 4.2 kilometers per day. And in the next 8 days, his average dropped to 3.75 kilometers per day. The question is, how far must Amir walk per day for the remaining 12 days to achieve his goal average of 5.5 kilometers per day? This problem involves logical reasoning and proportional thinking, where we must analyze previous data and plan the remaining distance. It also reflects real life. Sometimes, when our early progress is slow, we need to increase our effort later to reach our goals. Why guess and check? I decided to use the guess and check strategy for this individual task because it promotes active exploration and reasoning. According to Horton 2024 from Teacher Vision, this method encourages learners to think logically by making assumptions, testing them, and revising their ideas based on evidence. Unlike formula-based methods, guess and check allows us to visualize relationships between data and observe how small changes affect the outcome. It's simple, flexible, and helps develop deeper understanding, which especially for learners who prefer hands-on or investigate approaches to problem solving. We choose this form representation because it supports trial and improvement based on evidence. Math in Action states that this approach strengthens metacognitive awareness, allowing learners to reflect on their own thought processes and refine their strategies. I also decided to represent my reasoning in both a table and a line graph. These visuals make the data more meaningful and easier to analyze. They show the trend of Amer's performance clearly, from slow progress to improvement, and they align with Polya's idea that problem solving should be a visible, step by step process. The guess and check method aligns naturally with Polya's four-step problem-solving model, which consists of step 1, understanding the problem, step 2, devising a plan, step 3, carrying out the plan, and last step is looking back. These steps provide structure and help ensure that every stage of problem solving is logical and reflective. As the Old National Academy notes, this framework encourages learners to pause, analyze, and evaluate their progress, which is exactly what happens during guess and check. Applying the strategy. Let's begin with step 1, which is understanding the problem. Amer's total goal is 30 times 5.5 equal to 165 kilometers. He has already walked 42 kilometers in the first 10 days 130 kilometers in the next 8 days, making a total of 72 kilometers so far. That means he still needs to complete 93 kilometers during the remaining 12 days. So, the challenge is to find how many kilometers per day Amir must walk to cover those remaining 93 kilometers. This step is crucial because understanding the relationship between totals, averages, and time forms the foundation for correct reasoning. In step 2, I devised a plan using the guess and check strategy. This means I would make a reasonable guess for Amir's daily average, multiply it by 12 days, add it to the 72 kilometer already completed, and compare it with the target total of 165 kilometer. If the result is lower than 165, the guess is too small. If it is higher, the guess is too large. Through systematic adjustments, we move closer to the correct value. This approach is simple, but it encourages analytical thinking, pattern recognition, and logical refinement, all key components of mathematical reasoning. Step 3. Carry out the plan. Here is the table of my results during the guess and check process. You can see below the table below. Each attempt brought me closer to the correct answer. From this table, you can see that 7.75 km per day gives the exact total of 165 km. This process clearly shows how guess and check combines logic, evidence, and persistence. It encourages learners to use reasoning, not memorization, to reach a correct and meaningful solution. In this final step, looking back, I verified my solution. It is 10 times 4.2 plus 8 times 3.75 plus 12 times 7.75 equal to 165 kilometers. When dividing 165 by 30 days, Amir's overall average is 5.5 kilometers per day, exactly matching his goal. This step highlights the importance of reflection, which is checking our work not just to confirm the answer, but to understand why it works. This reinforces mathematical confidence and ensures the reasoning is consistent. Visual representation. This line graph shows Amir's average walking distances across three time periods: days 1 to 10, days 11 to 18, and days 19 to 30. The line begins at 4.2, dips slightly to 3.75, and then rises sharply to 7.75 km per day. This visual representation tells a clear story. Amir slower progressed early and required much greater effort later. According to Yumiati and Novianti 2023, visualizing mathematical data helps learners identify patterns and interpret meaning effectively, which is exactly what this graph achieves. Interpretation of results. The results show that Amir must walk 7.75 kilometers per day during the final 12 days to achieve his goal. This demonstrates how mathematical reasoning helps in planning, tracking progress, and making decisions. The situation also reflects the value of perseverance. Just like Amir had to increase his effort, learners must stay consistent to meet their academic goals. Mathematics, therefore, becomes not just a subject of numbers, but a way of thinking critically and solving real life problems. analysis and reflection. The guess and check strategy strengthened my logical reasoning and helped me understand how evidence supports decision making. It transformed problem solving from a guessing game into a structured and reflective process guided by logic. This strategy also taught me patience and perseverance. Every wrong guess was not a failure, but a clue leading closer to the right answer. Through this process, I realized that mathematics encourages us to learn from mistakes and to refine our thinking continuously. When comparing my line graph with the group's bar chart, I found that different representations can show the same information in unique ways. The bar chart displays data more clearly by category, while the line graph highlights trends and progression. This comparison helped me see how using multiple representations can enhance both understanding and communications in mathematics. In summary, this task demonstrates that mathematics is not only about calculation, but about reasoning and reflection. The guess and check strategy, supported by Polya's four-step model, provides a systematic and meaningful way to solve problems. It encourages learners to explore, analyze, and verify their results rather than memorize formulas. This method also builds confidence, persistence, and analytical skills, which are essential for lifelong learning. Ultimately, this task helped me see that every mathematical problem can be a journey, which is one that develops logical thinking, creativity, and self awareness. That concludes my presentation. Thank you very much for listening. I hope this sharing has shown how the guess and check strategy, together with Polya's four-step model, can make problem solving both practical and meaningful. Thank you.